Okay, matrix determinants, but this one with algebra, so you can't just put it into your calculator. We want to show that C is non-singular, so you need to remember that that means the determinant of C is not equal to 0, because singular matrices don't have inverses, so the determinant is 0. Okay, so the determinant is not 0, so we're going to find the determinant. So remember with this, we take any of the rows or columns, doesn't matter. Most people usually just do the first row, so I'll do that. So we take 2, cross out the row of column, and we do 2 times the determinant of what's left. Then we move along. So the pattern goes, you take the positive of the first number, the negative of the next number. So that's going to be subtract, and it's negative 2. So column, determinant of what's left. Okay, then the pattern goes positive for the last number. So plus 4, cross out the 4 row and column, determinant of what's left. Okay, so that's going to be 2. Now we've got 2 by 2 determinant, so that's just x minus 2 times x minus 2 times 3. So we go that diagonal minus the opposite diagonal. Same for the next one, so plus 2. So we're going to have 5 times x, subtract negative 1 times 2. And then the same with the 4. Being really careful with that one. And then we're just going to expand and simplify all that. Okay, so that's our determinant of C. And what we've got to do now is show that that is never less than 0. Yeah? It's going to be a few things. We've got to work with a quadratic here now. So we know it's a positive quadratic, so its graph is going to be that way up. So we need to find the minimum point of our graph and show that that's not below the x-axis, so that our graph goes something like this. Different ways you could do this. So you could, for example, differentiate that expression. I'm going to get 4x plus 10. If I make 4x plus 10 equals 0, I'm going to get that x is negative 5 over 2. Then I could find y by substituting that into our expression, and we should be able to get to y is 79 over 2, and then you can do an explanation about how that's the minimum point of the graph. So y is always, if you say y is our expression, then y is always greater than 0. Therefore, determinant is always greater than 0. You can also do this by completing the square. So I've got my determinant of C is 2x squared plus 44. So that's 2 lots of x squared plus Okay, so that's plus 63 over 2, which does mean, having skipped ahead on this one and used the answer that we had in the mark scheme originally, that's actually wrong. That should be 63 over 2, but that's still bigger than 0. So we've got this determinant here. So what we can say now is this bit is obviously greater than 0. And here we've got 2x plus 5 over 2 squared. Well, that's always going to be greater than 0, because squares, if you square a number, it always is positive. So therefore, determinant of C is greater than 0 for all real values of x. Z for all values of x. Okay, it's always